In today's lab, we're looking at the relationship between drag force and terminal velocity. So when an object falls through the air, it's going to hit the air particles on its way down. Those air particles are going to exert a force on it, or an air resistance, that we call the drag force. This drag force is going to continue increasing as the object's velocity increases, and it will continue increasing until the drag force balances or equals the weight of the object. At that point, the acceleration goes to zero, the object stops accelerating, and it falls with a constant terminal velocity. One thing that contributes to how much drag an object experiences is its cross-sectional surface area. Now, this is not a relationship that we're going to be experimenting with the data, but we are going to look at it briefly right now just to give you an idea of it so you can see it in action. So if you look at your coffee filters, you'll see that they have some sort of cross-sectional area, the circle that the air is going to hit as it falls through the air. Now go ahead and take two of these, and you can set the rest aside for right now. Alright, so what I want you to do is take one of these and kind of crunch it up just a little bit more so that you have a smaller surface area. Just fold the sides in like this, and then you'll have a much smaller area. Then take the other one and flatten it out a bit. Don't flatten it out all the way, but just flatten it out some so that you have a much larger area. So compared to the two now, this one has a much larger area, this one has a much smaller area, so we know that this one should experience less drag, this one should experience more drag. Since more drag equals a lower terminal velocity, the one with more drag should experience a lower terminal velocity and should take longer to fall to the ground. So we can test this. If we hold them both up above our head and drop them at the same time, we should observe that the one with less drag or less surface area is going to fall faster and reach the ground first. So go ahead and try this. Lift them both up above your head and then let them both fall at the same time. And we see that as expected, the one with the smaller surface area, the less drag, hits the ground first, and because it has a greater terminal velocity. So for the same reason, just go ahead and take the rest of your filters and kind of flatten them out like you did before. So just flatten them all out so that they all have about the same large surface area. This will slow them down, let them reach terminal velocity faster, and it should give you results for the experiment, should give you better results for your experiment. The setup for this experiment is very simple. All you're going to need is a camera, such as a cell phone, tablet, or you could use a webcam, and just point it at a wall. So the wall you're going to want to use, you need a dark colored surface, so the coffee filters are white, so you want a dark surface so that they show up nicely against that. And you're also going to need a nice vertical line and a horizontal line that you can use to line up your X and Y axes on the computer. So in my case, this door trim here, like one of the edges of it, makes a nice line for the Y axis, and then either the floor line or along the baseboard there, the top of the baseboard, makes a nice line for the X-axis. So you want that, and then you're going to place your camera about 2 meters away from the wall or away from where you'll drop the coffee filters, and prop it up just a little bit so it's a little bit higher. You're going to want, if you're using a cell phone, just use the wood block here like this so that you can have it'll be a nice stand, so just use the rubber bands with your cell phone. There's instructions for that, so just follow that. Very simple. So to set that up, you're going to want to point it directly at the wall. Whoops, face it around that way. So if you're using the camera on the back, then definitely have it pointing towards the wall. Make sure that it's pointing directly at the wall. If it's not, don't put it at an angle. If it's like this or this, that's not going to work. So make sure it's pointing straight at the wall. Then you're going to need a tape measure, or you could use a meter stick if you have one of those. So if you use the tape measure, just set the length to exactly 1 meter, and that's 1 meter on the tape portion of the measure, not this portion where you have the where it rolls up inside, but 1 meter like this, and then just place that on the floor right in front of where your camera is facing. So then check your camera, make sure that both ends are inside the view of the camera. So in my case right now, They are not both in view, so I'm going to just slide this over a little bit, and hopefully that will line it up. And that looks pretty good, so we can see both the left edge and the right edge of the tape measure. Now, if you have an iPhone or an iPad that you're using for recording on, this is going to apply to you. Go into your camera settings, the phone settings under camera, and make sure that you've changed the camera format to most compatible and not high efficiency. If you have a high efficiency format for your videos, the program tracker on the computer will not work with that. It won't accept those files. So just go ahead and change the setting before you record anything. Make sure that it's on most compatible format. You're going to do separate clips for each of the coffee filters. So 1, 2, 3, 4, and 5. Each time that you do it, hold up that number of fingers in front of the camera so that you have recorded how many filters are being dropped. You won't be able to tell just from the picture. And even if you said it out loud, if you're looking at it later where you don't have the audio, then it's good to be able to see visually how many there are. So I'm going to go ahead and start the camera. I'm going to show it one finger, and then I'm going to drop one coffee filter. All right, so just separate one coffee filter from the stack, lift it up above your head, and hold it in front of your dark surface if you have that, and then let it fall to the ground. Then I'm going to go ahead and stop the camera. And I've started it again. This time we're going to go ahead and do 2 coffee filters. So just separate 2 from your stack, show 2 fingers to the camera, and then lift them above your head. Let them drop to the ground. You'll notice this time it fell a little bit faster. That's because the weight has been increased. So I've stopped and started the clip again. This time we're going to do 3 coffee filters. So I show 3 fingers to the camera, separate 3 filters from my stack, and let that fall to the ground. Make sure that you're always lifting it above your head so that it has the largest distance or the longest distance to fall. If you have it just a short distance, it may not have time to reach terminal velocity, so make sure you're lifting it high enough up before you do that. All right, now we've got 4 filters. I'll separate 4 filters from my stack, lift them up, let them fall. Stop the video, start the video, 5 filters this time, and we'll lift them up and let them fall. And that's it. Once you've gotten all of that data recorded, you can take the video clips, each individual video clip, and export them however you want so that you can get them onto your computer if you have iCloud or Google Drive or email. However works for you, just make sure you send them over to the computer like that. The reason we have to do them in separate clips is the program tracker that you'll be using to analyze them in. Sometimes it can't handle very long videos, so it's good if you can have them broken up into shorter clips. Even if you did record them all as one clip, just one long video with all of the drops in them and fingers in between 1, 2, 3, 4, and so on, make sure that afterwards you divide them up into separate clips if you choose to do it that way. Make sure that you read your lab documents carefully. They have a lot more instruction and background information on the experiment than what I showed in this video. So make sure you look through that carefully before you do the experiment and follow along with that. And good luck with your experiment.